Hi, I am Deepa. Today I am going to discuss about one of the applications of finite state machine, that is traffic light controller. Here two conditions are considered. One is north-south and other one is east-west. Three signals are there in traffic light, as you all know, that is red, yellow and green. Red represents stop, yellow represents ready, green represents go. The same can be represented as states S0 to S5. S0 is the state where north-south is green, east-west is red with the delay of 15 seconds. S1 is the state where north-south is yellow, east-west is red with the delay of 3 seconds. S2 is the state where both north-south, east-west are red for delay of 3 seconds. S3 is the state where now east-west is green, north-south is red with the delay of 15 seconds. S4 is the state where east-west is yellow and north-south is red with the delay of 3 seconds. S5 is the state where both north-south, east-west are with the red signal for delay of 3 seconds. This can be represented in the form of state diagram. Here S0 is the state which represents the reset, and it is also the state which represents north-south as green and east-west as red. If delay is less than 15 seconds, we will remain in S0, else it will move to S1. If delay is less than 3 seconds, it will remain in S1, else it will move to S2. If delay is less than 3 seconds, it will remain in S2, else S3. Again here, if delay is less than 15 seconds, it will remain in S3, else to S4. If delay is less than 3 seconds here, it will remain in S4, else to S5. If delay is less than 3 seconds, it will remain in S5, else it will move to the state S0. The same can be written using VHDL. First, we have to include the library IEEE, then the package standard logic 1164.all. Here, the inputs are clock and clear, outputs are 6 LEDs, so represented as 5 down to 0. Here, component clock divider is required to reduce the delay of the clock of the target device. Another component FSM is required here for converting the state diagram into the program. Now two signals are required, that is clear and clock D. Two port instantiations are made, one is for clock divider and another one is for FSM. First we will see the FSM program. In FSM program, inputs are clock and reset, outputs are 6 LEDs. Here the states S0 to S5 are designed as the user defined states and with the name as state type. Here the maximum count is taken as 15, so the count is declared with the 4 bits as 3 down to 0. Maximum count of 15 seconds is given by the name sec5 and declared as constant. Another with the 3-second delay is given as name sec1 and declared as a constant. So now we will write in two processes. First process is C1, and if reset is made as high, we will remain in S0 and count is made as 0, else rising edge of the clock is detected. Then we have to check if in S0, if delay is less than sec5, it will remain in S0. Else it will move to S1 and count is made as 0. The same continues for state S1, S2, S3, S4 according to the state diagram. Now when in S5, if count is less than sec1, we will remain in S5 and count is incremented, else it will move to S0 state and count is made as 0. In all other conditions, it will remain in state S0. Another process is required to state the LED conditions. So when in S0, north-south will have green LED glowing and east-west will have red LED glowing. First 3 bits are for east-west, next 3 bits are for north-south. Next, yellow-red combination, next red and red combination, next red and green, red and yellow, and red when in S5. So now we will see this how it is implemented in the Xilinx ISE 14.7. In Xilinx ISE 14.7, target device, that is XC3S50, which is present in our lab, is chosen, project is created, and there files are added. The main program file is added here and 2 components, that is clock divider and FSM is added as the component programs here. Now once the program is written, we have to synthesize the program here. Once it is synthesized and all errors are removed, we should go for implementation of the design, which consists of translate, map, place and route. After that, we have to generate the bit file using generate programming file. After this, we have to configure the target device and dump the bit file on the target device, that is XC3S50. So here configure the target device, click OK here, then select the boundary scan, right click here to initialize the JTAG chain, click S, bypass the unwanted device here, select the bit file generated, select XC3S50, that is the target device, click apply, then OK. So now you can see that with the green color target device is selected. There you have to assign the new configuration file, select the bit file. Now you can program. Once we program, bit file will be dumped on the target device, that is XC3S50. Now we can see the LED conditions on the target device. So now first is green red, red yellow, then red and red. Now red and green for the longer duration. After that, from green it will move to yellow, and then from yellow to